Looking at Saturn and its major moons from above reveals a unified rhythm. Titan and Enceladus, and all move like clockwork, orbiting in the same counterclockwise direction as the planet's rotation, but far out in the reaches of Saturn's gravitational influence. Across an isolating void of nearly 13 million kilometers, prowls an object that moves in isolation. This is Phoebe. It moves backward in a clockwise retrograde orbit that crashes directly against the flow of the rest of the Saturnian system. Because planets and moons form from the same spinning disk of gas, they almost universally orbit in that same direction. If Phoebe had formed alongside Saturn, the drag of that gas cloud would have forced it into a prograde path. This backward motion is a smoking gun. Phoebe is an immigrant captured by Saturn's gravity long after the system formed. For thousands of years, astronomy was limited by what the human eye could see through a telescope that changed in the 19th century with the dry plate photographic revolution. For the first time, astronomers could leave a camera shutter open for hours, allowing light to accumulate on glass plates and reveal objects far fainter than the eye could detect. 28 A team from the Harvard College Observatory set up an outpost in the thin, dry air of Arequipa, Peru, using the 24-inch Bruce telescope. They began a deep photographic survey of the southern sky. Human analysts back in Massachusetts used magnifying loops to pore over the resulting glass plates. In 1899, William Henry Pickering spotted a tiny magnitude 15 speck, roughly 4,000 times fainter than the limit of the naked eye. Pickering traced the path across multiple nights. The background star stayed fixed, and while Saturn moved, this speck moved with it. But its specific trajectory didn't match any known satellite. This faint smudge on glass was the first natural moon in history, discovered by photography, providing the first evidence of a world snatched from the deep solar system. Visiting Thebes was a logistical challenge. Its extreme distance and backward orbit meant a spacecraft entering Saturn's inner system could never match its speed or direction for nearly a century. We only saw Phoebe as a dark, jagged blob. When the Cassini spacecraft arrived in 2004, mission planners realized they had a single chance before firing the critical engine burn to enter orbit. They could pass by Phoebe on their way into the system. It was a one-shot intercept. Once Cassini settled into its final orbit, it would never have the fuel to go back during a flyby. At 5.8 kilometers per second, Cassini's cameras transformed the dark dot into a scarred world dominating the surface. Is the Jason crater, a massive impact basin, 101 kilometers wide, merely half the diameter of the moon itself. Surviving a hit of that magnitude tells us Phoebe is a solid, cohesive body and not a loose pile of rubble like some asteroids. Saturn's regular moons are mostly pure porous ice, registering a density of 1.0 gram per cubic centimeter. By measuring how the moon tugged on Cassini, scientists calculated Phoebe's density at 1.63, implying it's up to 67% rock. Cassini spectrometers provided the second clue, detecting carbon dioxide trapped in the surface rocks. Because CO2 boils away in the warmer inner solar system, its presence confirms that Phoebe formed in the deep freeze beyond the orbit of Neptune. This aligns with the Nice model, which suggests that 4 billion years ago, the giant planets migrated, throwing countless icy bodies into the sun or out toward interstellar space. In that chaos, a few objects were scattered inward and captured. Phoebe is a surviving planetary embryo from that era. It had begun separating into a rocky core and icy mantle before it was flung towards Saturn and held prisoner for 4 billion years, even in its lonely orbit. Phoebe is active for billions of years. A rain of micrometeoroids has blasted its dark surface dust into space because Phoebe's gravity is weak. This dust is easily entering its own retrograde orbit around the planet. In 2009, Spitzer discovered this escaping dust forms the enormous Phoebe ring, spanning 16 million kilometers. It could hold 1 billion Earths invisible to the naked eye. It tilts 27 degrees from Saturn's main rings and shares Phoebe's backward orbit. These traits confirm that Phoebe is a dust engine, constantly eroding to create the largest ring in the solar system. In 1671, Giovanni Cassini observed that the moon Iapetus had a yin-yang appearance, one hemisphere white as snow, the other black as coal. Iapetus orbits prograde, while dark dust from the Phoebe rings spirals beamward in the opposite direction, creating a high-speed collision course as Iapetus flies through this cloud. Its leading hemisphere acts like a windshield, accumulating dark dust over billions of years. A frozen refugee from the Kuiper Belt, held prisoner by Saturn's gravity, is effectively spray painting its neighbor from millions of miles away. Phoebe remains a relic of the early solar system, a reminder of a time when the planets themselves were on the move.